Unit 12, day 2. Here we go. Determine if the sequence below is arithmetic or geometrics, and determine the common difference or ratio in simplest form. So looking at these, looks like we're increasing by 3 times the amount as the previous number. 4 times 3 is 12, 12 times 3 is 36. When it's a geometric sequence, a lot of times it will help you, especially when it comes to if they're dividing. Just take the second number, divide it by the first number, and that will give us 3. So that's going to be our ratio. But anyway, the first blank here, you're going to write geometric. If it's a geometric sequence, then we are dealing with a ratio. And that ratio is 3. Okay, looking at example 2, determine if the sequence below is arithmetic or geometric. We're getting smaller each time, and it doesn't look like we're subtracting. So second number over first number, that would simplify to 1/4. So this is geometric. If we're multiplying or dividing, it's a geometric sequence. And then it would be a ratio that we're dealing with, and that ratio is 1/4. Example 3, determine if the sequence below is arithmetic or geometric, and then to determine the common difference or ratio. Here we can tell we are subtracting by 4 each time. So if it's subtraction or addition, that is arithmetic. And this time we have a common difference, not a ratio. And that would be -4. Example 4, determine if the sequence below is arithmetic or geometric. It looks like we are adding by 5 each time, so addition, that's arithmetic. Therefore, we have a common difference. And that difference is 5. So hopefully you get the pattern by now. Let's go ahead and jump over to example 7. The first 3 terms of a sequence are given. Round to the nearest thousands if necessary. Find the 7th term. So what we want to first identify is, are we dealing with arithmetic or geometric sequence first? Looks like we are dividing by 2 each time. Second number over first gives you 1/2. So that is our ratio. I'm going to give you the formula for how to find the 7th term of a geometric sequence. Here it is. Oh, that shouldn't be that. It should be subscript, my bad. Okay. A subscript 1 means start with the first number. R stands for the ratio, which is 1/2. N minus 1, N represents how many terms we're dealing with. And nth means, well, whatever all of this is, once you plug it into your calculator, that will be the number of that particular term. Now from here, it's simply plugging it into your calculator. So I'm going to go ahead and I'm going to give you the answer. Which would be 0.563. Example 8. The first 3 terms of a sequence are given. They want us to find the 46th term. Now we have to figure out, is it arithmetic or geometric? In this case, arithmetic. They are adding by 9 each and every time. So we have a difference of 9 here, which means since it's arithmetic, that's going to require a different formula. A subscript 1, first number, plus the difference, 9, times n minus 1. N represents what term are they wanting us to identify? And then all of this will equal whatever the 46th term is, which is 414. Example 9, the first 3 terms of a sequence are given, round to the nearest thousandth. So let's start with determining, is this geometric or arithmetic? This would be geometric. Our common ratio is 3/2. So we're going to need this formula here. And then start substituting. Plug that into your calculator. And that would be your answer. And 11, let's see. Looks like here they're multiplying by 3 each time, therefore we have a ratio here. Now looking at example 11. Looks like we are subtracting by 6 each time. We have a common difference of -6. Here's that formula. Just plug in. For a final answer of 30, that's the 47th term. Example 12. Gianna is a teacher and takes home 75 papers to grade over the weekend. Awkward pause, sorry. She can grade at a rate of 7 papers per hour. How many papers would Gianna have remaining to grade after working for 6 hours? So this is going to be an arithmetic word problem. Now you might be tempted to say, well, then we're going to start with 75, but we're not. We're not going to start with 75. And I'm going to point out a key word here. They want to know how many papers are going to be left to grade after working. That's key word there lets you know you don't want to start with the initial amount. You want to start with the amount after the first hour. So take 75 and subtract 7 from it, because that's how many papers they can grade in 1 hour. And that would give us 68. Yeah, 68. So start with 68 here. And then -7, that's the difference. That's how many paper they're grading each hour. So they're going to be decreasing by 7 each hour. And then n-1, n represents the amount of hours we're trying to solve for here, -1. And then from here, you're just plugging this into your calculator. Your final answer would be 33. Javante just got hired for a new job and will make 41,000 in the first year. So we're going to start with 41,000. They were told that he can expect to get a raise of 1,500 every year. It will always be the exact same amount, 1,500 every year. So this is an arithmetic word problem. So plus 1,500 times how much money in salary would Javante make in his 11th year of working? So n-1 or 11 minus 1. Plug this into your calculator and you would get all right, example 14. The bouncy ball is dropped such that the height of its first bounce is 4.75 feet, and each successive bounce is 72% of the previous bounce's height. What would be the height of the 6th bounces of the ball? So now we're dealing with a geometric word problem. Our ratio is that percentage, but convert it to a decimal. So here, start with the initial amount, 4.75. Multiply by 0.72. Raised to the n-1, and here n represents 6. Plug all that into your calculator and you would get 0.9. Okay, here we are investing 1,800 in an account that pays 1.75% interest compounded annually. Assuming no deposits or withdrawals are made, find out how much money Natalie would have in the account 17 years after her initial investment. So here we have that key word again. We don't want to know how much money, we don't want to start with 1,800. We want to know how much money after each year. So we want to know how much money is going to be account after the first year. So start with 1,800 and multiply that by 1 plus 0.0175. 1 plus, always use 1 plus in this format. 0.0175, that's the rate converted into decimal format. Okay, if you plug this in your calculator and solved, you would get 1831.5. This is how we want to now start the remainder of this problem. 1831.5. This is the amount after the first year. After. So start with that. And then 1 plus the rate again. And now raise it to the n minus 1. And that will give us 2417.50. Example 16, we are given a large box of chocolates. If we eat exactly 2 chocolates per day, how many chocolates would be remaining 9 days after the birthday? So we don't want to start with 30. We want to know how many after we start eating these things. So the initial amount was 30, but first subtract 2 from that. So start with 28. And we will be eating 2 every single day. So minus 2 times in this case, 9 minus 1. Plug all of that into your calculator and you have 12 chocolates remaining. Have a good day.